Hello everyone, welcome to StudyIQ. So what we have learned till now, we have seen basic remainder theorem and we have seen some patterns. We have seen the power cycle, last two digits. We have seen the divisibility rules completely, but I missed out the divisibility rule of 17, which I will be discussing today in this session. Then what we have done, we have seen Fermat Theorem and we have seen how to solve questions or how to find remainders by using Fermat Theorem. Now what is left out is Chinese remainder theorem. So I will be covering that Chinese remainder theorem in this video. I will also cover the divisibility rule of 17 here. Then I will cover the last topic, that is constant remainder theorem, which is a very simple topic, in the next video. Okay, so that's the agenda. So what is the divisibility rule of 17? See, if you remember what we have done in case of 7 and 13 and 11 etc., or to be more particular, 7 and 13, what we did, we know that 10 raised to 3 divided by 7 will give you minus 1 as the remainder, right? So we used this to solve questions, right? Then 10 raised to 6 by 7 will give you 1 as the remainder. Why? Because minus 1 into minus 1, applying basic remainder theorem, right? We have seen this. So since it is 10 raised to 3, we group it into group of 3 from the rightmost side. And since minus and plus alternately, we put minus plus alternately, right? So if you remember this question, 200, 300, 100, 355. Okay, so how will you solve this question if it is divided by 7 and I'm asking you remainder? How will you solve this? You will group into group of triplets from the rightmost side, okay, and put plus minus signs alternately. Bring together the groups with the same signs, right? So you get 655 minus 300, you get 355. You divide the 3-digit number by 7 and see the remainder, that is 5. And 5 will be the remainder if you divide the bigger number with 7. So that's how we have solved divisibility of 7, or divided by 7, what is the remainder. Same was the method for 13 also, except the last step, because there the divisor is 13, so this become 13. So I can change the question if you want, put here 13, so this become 13. That's the only difference, and the remainder will change accordingly. Now same as the method that we are going to use in case of 17 also. Now, if you see 37, divisibility of 37, when we discussed, we understood 1000 by 37. What is the remainder that we got? 1. Or 10 cube by 37, you got 1. So 10 raised to 6 by 37 also will be 1. 10 raised to 9 by 37 will also be 1. So there is no, in case of 37 also you will group into group of 3 because this is 3. But you will put only plus 1. Okay, you will put only plus signs, you don't put minus signs. Why? Because in 7 and 13 you get plus minus alternately. Remainders as minus 1, plus 1, etc. Here only plus 1 as a remainder. So you put only plus 1. And if you remember, we have solved this case, right? 1, 2, 3, 1, 2, 3, etc. up to 300 digits, right? So that means 100 groups are there. So when you group into group of 3, 100 groups are there like this. Now each group is 1, 2, 3. So total 1, 2, 3, 0, 0. That you need to divide by 37. If you need to find this bigger number, divide by 37 remainder. You can also divide this by 37, find the remainder. Or this you can further simplify by grouping into group of 3 again. This you can write as 312 by 37 and find the remainder. And you got the answer as 16. Okay. Now let me discuss about 17 now. In case of 17, the rule is 10 raised to 8 by 17 will give you minus 1. So based on this only you are going to make the rule. So if it is 10 raised to 8, means you need to group into group of 8. 10 raised to 8 by 17 is giving minus 1, means 10 raised to 16 by 17 will give you plus 1. So now next multiple of 8, that is 24 by 17 will give you minus 1. Then plus 1, minus 1, plus 1. So you understood you need to group into group of 8. And you need to put plus minus. Earlier, in case of 7, 10 raised to 3 by 7 was minus 1. So group into group of 3, then plus minus. Here group into group of 8, plus minus. Now if you need to check this, just before we have learned about Fermat Theorem. By using that you can check it, right? Why? Because these two are co-primes and 16 is the Euler's number of 17. So these two are co-primes and this is the Euler's number, means remainder will be 1. I hope this is clear for you. So divided by 17 remainder, you can either use Fermat Theorem or you can use this method. You can group into, if the number is given like that, you can group into group of 8. If the number is given like this, you can use Fermat Theorem. If the number, a bigger number is given, let's take a question. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 17. What is the remainder? What is your answer? Divide into group of 8. Put plus minus. What is the remainder? Remainder is 0. That's it. Otherwise, this question looks very big, right? But your answer is 0. How? You divide into group of 8. Put plus minus. Both will get cancelled out. Remainder is 0. Okay. What if there is... Okay, now let's suppose 1, 2, 3. Then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now how will you divide into group of 8? Divide into group of 8 from the rightmost side. So this is your first group and this is your second group. So this is plus, minus, plus. So plus and minus will get cancelled out. What is left out? 123. You can divide by 17 and you can see the remainder. So the idea is you don't want to divide the bigger number with 17. You can just divide 1, 2, 3 by 17. You'll get the answer. So if there is a 2 here, this becomes 2, 1, 2, 3 by 17. So I hope you understood the divisibility of 17. So we have covered divisibility completely. So 17 I missed out in the previous discussion. That's why I discussed. Okay. Now we are going to learn about Chinese remainder theorem. This is of higher level. It is not required for if you are preparing for IBPS, SSC, etc. If you are taking CAT, XAT or something like that, then it is required. Even then, this is going to be a round 2 question. But it's a sure shoot question. You'll get the answer for sure, but you may take some time. 1 or 2 minutes you may take. That's the only problem. Okay. So let's understand what is Chinese remainder theorem. Now, till now what we have seen is the case of factorizing the numerator. Here, you may need to factorize the denominator. Let's take one example. The same big number that you have seen, 1, 2, 3, 1, 2, 3, 1, 2, 3. Let's take up to 300 digits. Okay, 300 digits. That means 100 such groups will be there, ending with 1, 2, 3, obviously, right? Ending with 1, 2, 3. Previous will also be 1, 2, 3, like this. Divide by 99, see what is the remainder. Okay, so here you can't use Fermat theorem because anyway these two are not coprimes and finding that is very difficult. Better we have a better method. That's what we are going to discuss, Chinese remainder theorem. So here you need to factorize the denominator. So you can factorize the denominator 99 as 9 into 11. Okay, numerator is the same. Now what you need to do here is you need to divide the bigger number, that is the numerator, first with 9 and then with 11. That means you need to divide the numerator with 9 and 11 and see what is the remainder. Then I will tell you what is the second step. Okay, so what is the first step? What you need to do? You need to divide the numerator with 9 and then 11. See what is the remainder. See, dividing the numerator with 9 itself is a question. It's a CAT level question. Dividing by 11 is also similar, right? So that itself is 2 CAT questions. So you know how to divide, right? How you divide? And you know how to find the remainder when divided by 9, right? You take sum of digits till you get a single digit. So let's mark it as n. Okay, this is n. So let's find n by 9. What is the remainder? Okay, that is the first step. So n by 9, what is the remainder means? Sum of digits still get single digit. Sum of digits means 1, 2, 3 is one group. What is the sum? 6. How many such groups is there? 100. So total sum is 600. Take sum again, you get 6. And what is that 6? That 6 will be the remainder when you divide a bigger number with 9, right? So you take sum of digits till you get a single digit. So what is the remainder when you divide with 9? Then when you divide the number with 11, what is the remainder? How will you find it? I told you in case of 11 we have enough flexibility. We have discussed this in divisibility rule. You can group into 1, group into 3, group into 5, group into 7, group into 9, 11, etc. Now generally what you have learned or studied is group into group of 1. That is difficult here. You can't group into group of 1. But if you group into group of 3, this is going to be very easy. Because total 100 groups are there. 50 positive and 50 negatives both will be cancelled out. So you will get 0 as the remainder. That means when you divide by 9 you get 6 as the remainder. When you divide by 11 you get 0 as the remainder. So if I want to rewrite the number, how can you rewrite? So I hope you might be knowing this concept. The number I can write as divisor into quotient plus remainder, right? If I know the divisor and the quotient and the remainder, I can write. Now here I know the divisor, in this case 9. I know the remainder 6. I know the number also. So how can I write it? I will write it as n. The number is equal to divisor is 9. Let's write a quotient. Okay, let's write quotient as a. 9a plus 6. I know the remainder is 6. So this given number I can write like this. So 9, when you divide by 9, you get a quotient, but remainder is 6. Quotient is not important for me. Now, then how will you write this number when 11 is the divisor? You can write it as 11, some other quotient. A cannot be the quotient because divisor is different. Let's write another quotient, B plus 0. I hope this is clear. The same big number I can write like this. Okay, now what I need to do is, I need to look for a smaller number but a similar number. I need to look for a smaller number but a similar number which satisfies this two condition. Now, this is one condition, this is another condition. Let me see what are the, so let's take that again. N is equal to 9a plus 6. That's what the given number. Now, N is equal to 11b plus 0. That is also the given number itself. Why? Because if you write the possible numbers here, what is the first possible number? 6. Then you add 9, you get next number 15. Add 9, okay, then you get 24, then you get 33, then you get 42. It will go on, and finally somewhere you get this number. If you keep on writing this series, in the end you will get this bigger number. Why? Because this number is a part of this series, and this is actually an AP with a common difference 9, because the divisor is 9. So that's an AP with a common difference 9. You will definitely get this term at one point of time. Okay. So same way, if you write this possible numbers, what is the first possible number? 11. Because when you divide 11 by 11, you get remainder 0. So we are having remainder 0. Then 22, then 33, then 44. Then you keep on writing this. If you keep on writing this, finally somewhere you will get this term. So both will satisfy this. Both will satisfy the given condition, right? So that number belongs to both these series. So now, how will you find the remainder when the bigger number divided by 99? The method is, take the first common term which satisfy both the condition. That means I told you to look for a smaller number but a similar number. Similar number means 1, 2, 3, 1, 2, 3, 1, 2, 3 satisfy both condition, 9a plus 6 and 11b plus 0. So if you look here, 33 also satisfy both the condition, and that's why 33 is there in both. 6 is there here, but 6 is not part of this. So now if you write this, 33 is the first number which satisfy both this condition. What will be the next number? That will be, for that you need to add the LCM of 11 and 99. You add the LCM of 11 and 99, that is 99. So you add 99, you get the next number. Again add 99, you get the next number. Again add 99, you get the next number. So it's actually a series, or you are actually going to get an AP. And in fact, all the remainder questions are AP based question only. We will discuss in detail about AP later. But here, what is the first term if I ask you? 33. Second term, if you need to find 33 plus 99, 132. Third term will be 132 plus 99, 231. Fourth term will be 239 plus 99, that is 330. Fifth term will be 330 plus 99, that is going to be 429. If you keep on writing this, in the end what you will get? You will get 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, etc. Okay. Now, if you need to find the remainder when this number divided by 99, this will be same as that of, you take any number from the series, 33 or 132 or 231 or 330 or 429, any number you take from the series, divide with 99, see the remainder. Now, all the term in this series will give you the same remainder. All the term in this series will give you the same remainder. That's what constant remainder theorem. So you have an AP. Okay, let's take a simple AP. 2, 4, 8, 6, 10. It's an AP. You divide all the term with 2, you get remainder 0. Okay, or you take any term, divide with the common difference. What is the common difference? 2, 2, 2, 2. Divide with 2, all will give you the same remainder. Now, what is 99 here? 99 is the common difference. So, what is constant remainder theorem? Any AP, okay, just for your understanding, otherwise it's not important, okay. If we can solve this question faster, when I take the next question, you will solve it faster. So, what is constant remainder theorem? Any AP you take the common difference of AP, divide any term in the AP with the common difference, you get the same remainder. So here you know the common difference is 99. So divide any term with 99, you will get the same remainder. So 1, 2, 3, 1, 2, 3, 1, 2, 3 is part of the series. So when you divide 1, 2, 3, 1, 2, 3, 1, 2, 3, you get a remainder that will be the same as that of 132 by 99. That will be the same as that of 231 by 99. Or what is easy? Take the first term 33. So divide 33 by 99. What you get? 33 itself is the remainder. That means 33 will be the remainder when you divide 123, 123, 123 by 99. So what is your answer? 33. The first term what you are getting is your answer. You don't want to find these terms and all. This is not required. So basically what I need to tell you is the concept. So 33 by 99, 33 is the remainder. 132 by 99, 33 will be the remainder. So 132 by 99, you will get 33 as the remainder. Take the third term, 231 by 99, you get 33 as the remainder. Fourth term, 330 by 99, still you get 33 as the remainder. Any term for that matter in that AP you take, you get 33 as a remainder. So what we did, we have a series 1 2 3 1 2 3 1 2 3 etc., that is n. What, and you need to divide by 99, see what is the remainder, right? So what I did, I wrote this number in terms of 9 and 11 because 99 I factorized as 9 and 11. So how will I write in terms of 9 and 11? 9a plus 6, because when you divide that number by 9, 6 is the remainder. You know the divisibility of 9, you can do it faster. That number I can also write as in terms of 11, 11b plus 0, because when you divide that number by 11 you get 0. You know the divisibility of 11. Now I am looking for a number which satisfies both these conditions. So I got 33 as the number, first number which satisfies both the condition, and there itself you got the answer. Your answer is 33 itself. But to tell you why it is 33, I have explained you the other concepts. It is going to make an AP with a common difference 99. Why 99? The divisor is 99. So 33 plus 99, 132, etc. it will go. Finally you get 123, 123, 123. Now if you take any term from this AP, you divide by 99, you get the same remainder. Why? Because 99 is a common difference of AP. And what is the concept? Constant remainder theorem. Any term in the AP you divide with a common difference, you get the constant remainder. So rather than dividing this, you can divide the first term with 99. See what is the remainder? 33 itself. So actually the bigger number, you are finding the smaller number but a similar number. What is that? 33 is the smaller number but a similar number, because 33 is also part of the series. That is a part of the AP. Now how you are getting 33? You are factorizing and you are writing it as 9a plus 6 and 11b plus 0, and you see the number which satisfies both the condition. Why? Because n satisfies both the condition. So you need to find the smaller number which satisfies both the condition. Then you get the answer perfect. I hope you understood, right? One more example, you can take 1 2 1 2 1 2 1 2 etc. 300 digits. Okay, divide by 99 and see what is the remainder. So what you will do, you need to factorize the denominator 9 into 11. Now you need to write the bigger number in terms of 9 and in terms of 11, and then you need to see which number satisfies both conditions. So that's where you get the smaller and similar number, and that will be your remainder. As simple as that. Okay, so let's write. So first what we need to do is we need to divide by 9. That means you need to find the sum of digits till you get a single digit, right? So when n divided by 9, how will you get the sum of digits? How many ones are there? 150 ones are there. Okay, and how many twos are there? 150 twos are there. So you get the sum as 450. Further you get sum till you get a single digit, so you get 9. That means when you divide by 9, you actually get remainder 0. I hope you understood. Similarly, when you divide by 11, you need to find out, right? How will you find it out? Now in case of 11, you can, earlier in the previous case we grouped into triplets. Here you can group into group of 1. So you get 150 into 2 minus 150 into 1. Okay, because group into group of 1 plus minus. Okay, you starting with plus. So 2 is plus, 1 is minus. So that's why 150 into 2 minus 150 into 1. So what you get? You get 150 divide by 11, right? Because that is greater than 11. So you get 7. So 7 is the remainder. That means when you divide by 9, 0 remainder. When you divide by 11, 7 remainder. So how will you write n in terms of 9? 9. Write a quotient a plus 0. N is equal to 11b plus 7. So the number I can write as which satisfy both condition, n is equal to 9a plus 0, which is also equal to 11b plus 7. That's my number. What is that number? 1 2 1 2 1 2 up to 300 digits. Now will I get the first number which satisfy the condition? That means a smaller number and the similar number. So 9a plus 0 means what are the numbers? 9, 18. If you write this series, right? Then 27 etc. it will go. If you write this series 7, plus 18. It will increase in steps of 11. First will be 7. That means divide by 11 leaves the remainder 7, right? 25, etc. But I get a common term here. So 18 is the first such number which satisfy both condition. That means 18 is your remainder. Why? Because 18 is the number. 18 is a number. If you need to find the next such number, what is the common difference? 99. 18 plus 99, you get 117. Third number, 117 plus 99, 216. Fourth number, 315, etc., etc. If you go, finally you get 1, 2, 1, 2, 1, 2, 1, 2, etc. This number is a part of this series. Now, as per constant remainder theorem, you take any number from this, you divide with a common difference, that is 99, you will get the same remainder. So rather than dividing the bigger number, you can divide 18 with 99. You don't want to divide, you get obviously 18 as the answer. So I hope this is clear for all of you. Now let me summarize everything. So okay, I'll give you a question. N is equal to 1, 2, 3, 1, 2, 3, 1, 2, 3, etc. 300 digits. Now I need to find n divided by 2. What is the remainder? N divided by 3. What is the remainder? N divided by 4. What is the remainder? N divided by 5. What is the remainder? N divided by 6. What is the remainder? N divided by 7. What is the remainder? N divided by 8. What is the remainder? N divided by 9. What is the remainder? N divided by 10. What is the remainder? N divided by 11. What is the remainder? N divided by 13. What is the remainder? N divided by 37. What is the remainder? So I want you to find all this. So how many questions are there? So total 12 questions. You take 2 minutes and solve it, and that's enough for you. And that's the level of discussion we have done. So I hope you can solve it in 2 minutes. Okay, take 2 minutes and solve. What is the first question? N by 2. What is the remainder? What is the remainder? Remainder will be 1. Divisibility rule of 2. Last digit, right? Here last digit is 1, 2, 3 itself. So last digit is 3. So remainder is 3. N by 3. What is the remainder? What is the divisibility rule of 3? You need to take sum of digits. So sum of digits must be divisible by 3, right? So sum of digits means if you see the first group, you get 6. How many such groups are there? 100 groups. So 600, that is divisible by 3. So this is 0. Now remainder. N by 4, divisibility rule of 4, last 2 digits. So 23 means remainder 3. N by 5, divisibility of 5 means last digit. It has to be 0 or 5. So what is the remainder here? 3. N by 6, you understood the number is a multiple of 3 but ending in odd number. So remainder will be 3. N by 7, how will you do? You need to group into group of triplets from the right hand side. Put plus minus, right? So if you group into triplets, 100 groups are there. 50 plus group, 50 minus group, both will get cancelled out. Remainder will be 0. So what is n by 11 will also be 0. What is n by 13 will also be 0. Because all the three we can use the same method. If n by 7 is 0, n by 11 will be 0, n by 13 will also be 0. Same is the method. Then what is left out? N by 8. What is the divisibility of 8? Last 3 digits. So 120 is the multiple, so 3 is the remainder. N by 9. Divisibility of 9, sum of digits till you get a single digit. So 1, 2, 3 means 6. 100 groups are there means 600. Single digit means 6. So remainder is 6. N by 10. 10 divisibility last digit, so remainder is 3. 11, 13 is over. Now 37 we have already solved, right? So group into group of triplets, put plus signs only here. So 1, 2, 3, 00 you will get. You further group, so put plus, you get 3, 1, 2. Divide this by 37, you get 16 as a remainder. So I hope you have done with remainders completely. So what all things we did? We did basic remainder theorem. We discussed about Fermat Theorem. We discussed about Euler's number. We discussed about constant remainder theorem. We discussed about Chinese remainder theorem. We discussed about divisibility rules completely. We discussed about power cycle or last digit questions. We discussed about last 2 digits questions. This means divided by 10, a raised to x divided by 10, what is the remainder? This means a raised to x divided by 100, what is the remainder? Or divided by 50, 25, 20, 10, 4, 2, etc. What is the remainder? So these are the discussions that we have done so far, and we have discussed many different patterns, interesting patterns also. So I hope now you will be in a position to solve any remainder questions. Forget about the kind of exam that you're going to take. We have done this discussion at a much higher level. So you are taking IBPS or SSC, or if you are taking CAT or XAT or any exam, you will be in a position to solve any reminder question. Now in the next 3 sessions, what I'll do is I'll take up CAT questions which was asked earlier, and some difficult quant questions which is related to reminders. We will solve it. So I'll give you 3 more sessions for exclusively for solutions. With that, we will complete our reminders. So total 10 sessions were there in the series, including the questions. Now I've completed 7 sessions. So if you have missed out any of the session, you please watch these videos. So you'll be having complete idea about the reminders.